Hello, my name is Toni Marie Burkhalter, and I'm here to introduce you to the topics of myology and the muscular system for Kinesiology 186, or human movement. Today we're going to be talking about the muscular system. Muscle is amazing in the fact that it has the ability to contract, generate force, and propel our bodies forward. First, let's talk about the structure and functions of skeletal muscle. Did you know that for an average person, over 40% of the body weight is composed of skeletal muscle, and its most central role is generating movement? All muscle tissue is categorized by four characteristics: excitability, contractility, extensibility, and elasticity. Excitability or irritability is a term used to highlight the fact that a muscle will respond to a stimulus. Athletic trainers and chiropractors take advantage of this fact and can use electrical muscle stimulation to have a muscle contraction involuntarily on a patient. If you've ever needed rehabilitation and experienced muscle stimulation, it can feel like a vibration or a twitch in the muscle. Contractility or action refers to the muscle tissue's ability to shorten. A muscle shortens, and that movement allows the muscles to generate work. It's that contractility which permits your biceps brachii to perform a curl at the gym. Extensibility refers to the ability of muscles to lengthen. It's a good thing that the muscle can both shorten and then lengthen. It would be tragic if it remained fixed after it shortened. And lastly, elasticity refers to the ability of the muscle tissue to return to its original form after being stretched. When you bend down to touch your toes, your body will respond by having the hamstring stretch. But the stretch doesn't last a lifetime. Now that we understand what the four characteristics of a muscle are, let's talk about the types of muscle contraction. There are three different types of muscle contraction: concentric, isometric, and eccentric contraction. Concentric contraction is when the length of the muscle is shortened as it bears the external load. Like we discussed before, when you perform a curl at the gym, you are concentrically contracting the biceps brachii, and the muscle's ability to contract allows this to occur. But you may wonder what's happening to the triceps brachii when the biceps are working to lift that weight up. Well, the triceps are busy with an eccentric contraction when a curl is performed. This is the opposite of the concentric contraction. And an eccentric contraction results in the muscles lengthening or extending as it deals with the external load. It's protective in nature. In fact, if you put your left hand on your right biceps and simulate a curl, you'll notice that both the biceps on top and the triceps on the bottom will increase in tone. It's because they're both contracting. But your muscles can also perform a contraction without moving at all. This is referred to as an isometric contraction. Isometric in Latin means same length, and an example of an isometric contraction would be a wall sit or a plank where the body does not move, but the muscles are generating force to help you maintain that posture. Muscles are attached to bones and always cross a joint. Think about this. If a muscle didn't cross a joint, it wouldn't be able to produce any movement because we need a joint to allow for movement. With that in mind, let's learn some new terms. The origin is an important term, and the origin is closer to the midline compared to the insertion. The origin is where a muscle attaches at that location. But more accurately, the origin of a muscle is always attached to a bone that is fixed or not moving. In contrast, the insertion of a muscle is further from the midline and attaches to the bone that moves when the muscle shortens. But if we divide into the microscopic anatomy of muscles, such as your bicep brachii, the biceps are actually made of a mixture of different tiny muscle cells, where each cell is classified into a muscle fiber type. Two broad muscle fiber types are the slow twitch muscle fibers and the fast twitch muscle fibers. Depending upon your genetics and training, your biceps brachii, right here, could have a higher percentage of either slow twitch or fast twitch muscle fibers. Slow twitch muscle fibers move slower and would help a long distance triathlete in a 1-mile swim. Slow twitch muscle fibers are aerobic and slow to fatigue. On the flip side, fast twitch muscle fibers are more explosive in nature and generate a lot of force. Fast twitch muscle fibers are used when performing activities which require power or strength, such as an Olympic lift. Unfortunately, fast twitch muscle fibers can work anaerobically, but they fatigue quickly. So an elite endurance athlete likely has a higher percentage of slow twitch muscle fibers, where an Olympic powerlifter would have a higher percentage of fast twitch muscle fibers. Some people exercise for better sport performance, while others focus on exercise to help them look good. Often, men prefer to have larger muscles. Scientifically, the term muscle hypertrophy simply means that the muscle has become larger. And there are two types of muscle hypertrophy: transient muscle hypertrophy and chronic muscle hypertrophy. Let's provide an example of transient muscle hypertrophy. When I was in high school, we had a basement party at the house. It being the early 90s, my brother liked his tank tops, and immediately prior to the party, he would lift heavy weights to exhaustion, as well as doing push-ups and pull-ups, and in response, his muscles would swell as they were bringing more oxygen and nutrients to the muscle fibers for repair. He was swollen for about 2 hours due to that transient muscle hypertrophy, but by the end of the party, his swell was gone. But as he kept working out, every day he'd experience a little more chronic muscle hypertrophy. Chronic muscle hypertrophy occurs in response to repeated bouts of exercise. The muscles can actually increase in size and remain larger for more than a few hours. The body responds with chronic muscle hypertrophy by adding protein in the muscle to make the muscles larger and stronger. Scientists have found that fast twitch muscle fibers allow for hypertrophy sooner than slow twitch muscle fibers. This means that people with a higher percentage of fast twitch fibers may gain muscle mass much more quickly than people with slow twitch muscle fibers. So if you're struggling to gain muscle mass compared to your friend, it may just be that you're genetically inclined to have more slow twitch muscle fibers. Keep hitting the gym and enjoy the exercise for what it is.